Good evening, everyone. Welcome back to our 30 days free short-term training from Python to AI. So I know today is our last day, right, with respect to this particular program, and we are supposed to learn a use case, a project on KNN algorithm. So without no further delay, we'll start where we have stopped yesterday because we are supposed to cover a few topics that weren't discussed so far. So we'll just continue, friends. So in the previous class, we started with the use case where you know uh, we are working on a project with respect to banking sector, right? So in the banking sector, we are supposed to again check whether the customer is going to accept the personal loan or not. So all of these are the features that are available. In total, we have 14 features, 14 columns, and 5,000 customers, right? So our Y column, our target column is personal loan. Will the customer, accept or reject the personal loan? That is the use case that we are going to work on. So initially, I'll import all the required packages that are required. You know, pandas for data manipulation, pandas profiling for auto EDA purpose, matplotlib for visualization, k nearest neighbors, k neighbors classifier. This is for building the model. Okay, it uses the KNN algorithm and builds the model. And classification report and confusion metrics accuracy score. So these three functions. What are these three functions? Something new, and these are nothing but the metrics that we actually consider with respect to a classification problem. Okay, so we'll talk about these three functions. Might be later, not now. Then SMOT for handling imbalanced data sets. In order to balance them, we go and use SMOT, one of the technique that we generally implement in the real world. Then standard scalar for standardizing the data set, nothing but feature scaling. And train test split for splitting the data into train and test data, as well as grid search CV. Grid search CV is for uh, you know hyperparameter tuning. What is this hyperparameter tuning? A new topic. We'll understand. Everything we'll understand, friends. And finally, joblib. Joblib is for saving and loading the models. Okay, so the model that we build, it has to be saved so that it can be used on the new data for predictions. So we generally use pickle, if not joblib modules, joblib packages. Okay, so they actually help us to save and load the models again. Okay, so everything will be using whatever we are importing, each and every function, each and every sub package or sub module that we are importing, we'll be using in the code. Okay, so first I have to get the data. For that, I'm reading an Excel file using read underscore Excel. So I'll not waste my time because all these steps were being understood yesterday, friends. So there are 5,000 customers and 14 columns. Head function returns top 5 records by default, and info function, it provides the information about the data set where it gives number of records, number of columns, then column types, okay, the data types for each and every feature, also non-null count. And this particular code, line number 59 and 62, is for EDA, friends, using pandas profiling. So we got that HTML report right yesterday. So that HTML report can be generated. I'm not executing, I'm just skipping these two lines. Right. Then post EDA is done. I'm dropping the irrelevant columns like ID and zip code from the DF. So 14 becomes 12. I'm performing an in place operation, so 14 becomes 12. And I also observed that in the experience column, there are some values, there are some typos where experience cannot be less than 0, but still I have some negative values. I'm identifying them, and these are the values. So I'm applying absolute. All of them gets converted to positive values. So it's nothing but applying mod and checking for null values. We know that there is no null value present in the data set, so all the columns will get 0 as the output. Right. Then performing kind of feature scale engineering. So what exactly I'm doing is, since I have annual income refers to the income that a customer uh, earns per year. So I'm just converting the CC average credit card, spend how much a customer spends on an average with respect to the credit card. We have it per month. So I'm just converting it to year, multiplying with 1. So this is also done. Then separating my inputs and output. So for that, I'm dropping the y column from inputs, storing in x. So 5000 comma 11 will be the size of x inputs, and y will take only one. That is one column, nothing but personal loan, 5000. It's a series. It's not a data frame. It's a series. So in yesterday's class, we have understood till here. And if you are people who are joining new, or might be if you did not join yesterday's class, if you skip yesterday's class, I request everyone to go through the class yesterday that we have discussed, then listen this particular session, because you may or may not cope up, friends. Great. So now let us continue from where we have stopped yesterday. So post after splitting inputs and output, I'm splitting the data into 4 parts. What is the use, Akhil? It's simple, friends. Let me take X. X holds what? X holds all the inputs. Okay. And what does Y hold? Y hold only the output column, right? But what does our training, what does the primer says? You are supposed to split the data into 2 parts. What are they? Train data and test data. I hope you remember train data and test data. So what I'm doing is I'm splitting X into 2 parts, X train, X test. Okay, so from X, I'll make X into 2 parts, X train, X test. In the same way, Y also into 2 parts, Y train, Y test. So X train and Y train together will be training data set. X test and Y test will be testing data set. Right? So I hope it's clear. So don't get confused. We are not making into 4 parts. We are storing them into four different objects. Okay, 4 different variables. X train, Y train will be training data set. X test, Y test together it will be testing data set. For that, I'm using a function called train test split that we have imported, right, from scalar. So train test split of, for that I'm passing X and Y. The X and Y that we have, I'm passing into the function, and I'm also specifying the test size. What should be the test size? 30%. 0.3 represents 30%, right? So 30 divided by 100. So obviously it is 0.3. I need not explain all the calculations. I hope you are perfect. Sorry, my bad. So 30 divided by 100, 0 gets cancelled, it is nothing but 0.3. So if test is 0.3, train will be 0.7, 70%. Then What is this random state? Random state takes an integer friend. That means y, in general, you can also pass any integer. Okay, but why 42 is generally used, to reproduce the same split again and again. I'll talk about random state first of all, then I'll come to 42. What is this random state? Random state is a parameter, it's an argument that will be used in train test split, okay, to reproduce the same output again and again. Why? What is reproducing the same output? In the sense, assume that random state is not is used when you are splitting your data. When you are splitting the data into train and test, you did not specify random state. Assume. Okay, so test is 0.3, train is 0.7. You'll continue, you'll build the model, you'll get the output. Okay, assume that your output is also proper. You have observed very good result. Excuse me. You assume that you have observed good results, 97, 96%. So these are good results, right? Yes. So you got these results, and when you try to showcase the same results, you'll rerun this particular line again. Yes. So again, you have to rerun it to showcase your results to someone else. Then, you know, your results might be 94, 92. Why? Or 98, 97. Why? The reason is, here we are splitting the data, right, into train and test. Okay, assume I have 100 records, friends, 10 columns. Okay, ignore columns. Let us focus on records. 100 records are there. So train data should have 70 records. Test data should have 30 records. Am I right? Yes. So which 70 records should sit in train? Should 1 to 70 sit in train, or 30 to 70, 31 to 70 should sit in train, or what? This particular splitting will happen randomly. Okay, it happens randomly. And when you rerun this particular line of code for multiple times, you know, because of randomness, the observations get changed in the train data and also test data because we are rerunning it for multiple times. So obviously, your results will vary. I hope it's clear. So because of, you know because of this particular issue that we are actually facing, in order to reproduce the same split again and again, we'll come up with a parameter nothing but random state. Okay, so when you define an integer to random state, even though if you run this particular line for n number of times, by default it takes the same records. The records does not change. That is the use of random state in train test split. Okay, and we also have stratify. Stratify is equals to y represents. We are stratifying based on y output. So you'll have equal proportions in both train and test data of y class. Right? So let me show all the things by executing them. So together we have to run, friends. I'm executing all the two lines at a time. Done. Okay. So you see X train, X test, Y train, Y test. Actually, why did we get 3500 into X train and 1500 into X test? What did we discuss? 30% of the data into test data. So what is 30% of 5,000? 1,500? Yes. So this will be X test. And how can you tell it is random? Just observe the index, friends. It's completely random. And since we have used random state, even though if I run the same line for n number of times, the records doesn't change. The same records will be part of that particular object. See, did they change? No. So as an experiment, do one thing. You remove this random state and then rerun the same line for 2 times. Immediately observe the change. Right? So this is X test and X train 30%, 70%, in the same way 30%, 70%. So together X train, Y train talks together they are nothing but training data. X test, Y test together they are testing data. But before we build the model, we know that what do we know? Data is imbalanced. We are supposed to balance it. Yes. So how are we going to balance it? Using smooth. Okay. So I'm initializing smooth, friends, using the same random state. Okay. So initialized. I'll use this mode. Okay. From smooth, there is a method, nothing but a function fit underscore resample. You are going to fit on the training data, X train and Y train together. It is training data. Only we are going to balance training data. We are not going to balance testing data. We are not worried about testing data. But as we discussed, training data should be balanced. The reason is if the training data is not balanced, the model gets biased. For that reason, I'm balancing train data, okay, using SMOT. And SMOT is a oversampling technique, right? So just focus on the output of X train and Y train. But am I storing into the same variables? No. I'm coming up with two different variables, X train balanced, Y train balanced. These are the two different variables I'm coming up with. So the balanced data will be stored in X train balanced and Y train balanced. Done. So it's clear that if you observe here, X train balanced is 6328 cross 11, but X train is just 3500. What's happening is, you know, the minority class. For the minority class, what is the minority class in this data set? Customer accepting, because majority of the customers they reject. Yesterday we have discussed about this point, right? So customers accepting this particular loan, okay, personal loan, is the minority class. And for the minority class it comes with the oversampling. So that is the reason there is increase in with respect to the records. Even for white train balance, the same records. For better understanding, what I'm doing is I'm getting the shape of X train and Y train. So it is 3500 by 11 and 3500. The train data. But after applying smooth, it is 6328 cross 11 and 6328. Okay, so data got balanced now. Shall we proceed? Yeah, what are we waiting for? Then, since KNN is the distance-based approach, learning. Okay, distance-based logic is being applied. We are supposed to scale the features. For that reason, I am coming up with standard scalar. I am initializing standard scalar, applying fit underscore transform on X trained balanced only on the balanced data of training data. I'm applying this particular standard scalar. I'll get the transformed results. Okay, then I'm also transforming X test. Okay, X test data I'm also transforming. Done. So this is X test scaled, which is scaled, friends. Previously it is not scaled. Now using standard scalar we have scaled it. In total 11 columns. So till here we just completed the process of you know EDA, data pre-processing, then train test split, splitting the data, then balancing the imbalanced data set. All these steps has been done. Now we are actually starting the model building part. Okay, so for model building part, I'm initializing the function as is. I did not specify the nearest neighbor's k value. If I don't specify the k value, by default it takes 5 friends. How can we get the information? Go and you know read the documentation of k neighbors classifier. By default it takes 5 nearest neighbors. Okay, so I'm initializing the particular function. Done. So the function now is vanilla underscore KNN. So the base model is called as vanilla model. So what I'm doing is I'm using this particular vanilla underscore KNN the function, and I try to fit on the scale data. Okay, so on the balanced data only we have applied scaling. So the output of scaling is extreme scale, and for y we should not do any kind of balancing friends. I mean we should not do any kind of scaling. It is output, right? We should not touch the output. So I'm taking the y as it is, the balanced y, and I try to fit KNN. Done. KNN got fitted. Now, the model in the backend got trained. What is the next step? Take your model which got trained and get the predictions on test data. That's what I'm doing. My model is vanilla underscore KNN, and I'm using the model to predict on test data. Am I passing both x and y of test data? No, I'm supposed to pass only x. X test scale is what I'm passing, and I'll get predictions on test data. Where am I storing them? I'm storing them in y test pred. Y test pred is an array. See, these are the predictions. Okay, so these are the predictions for test data, and once if you have predictions and actual, these are the predictions and these are the actual. If you have both, you can get accuracy using accuracy underscore score function, and I'm storing the accuracy in accuracy variable, and I'm printing that accuracy to the console. What is my test accuracy? 91.6%. 91.6%. Akhil, at a glance, can you repeat what we have done? Simple, friends. What algorithm are we using? KNN. So I'm taking the function, I'm initializing it with the default parameters. Am I specifying any arguments? Any parameters? No. So if you don't specify any arguments, by default, some values will be considered. Okay, for the parameters, for the arguments. So out of those parameters that we have in the function, one of the parameter is k, and by default the value for k is 5. 5 nearest neighbors will be considered. Okay, so this was initialized and we are storing that function to vanilla underscore KNN. Now vanilla underscore KNN, using vanilla underscore KNN function, I'll fit on train data friends. That's what we have understood, right? As per ML primer, train the model on training data. X train, Y train. Together it is train data. Okay. Then what is the next step? Next step is once the model got trained, use the model to get the predictions on test data. When you want to get the predictions on test data, you should pass only inputs of test. Only inputs of test, not the entire test data. If you pass the entire test data, what will model predict? I hope you got the point. So only test inputs should be passed. That's what we are passing, and we are asking the model to predict. And model predicted, and we are storing the output to Y test predictions. So these are the predictions on test data. We also have the actual. Yes, we have actual. We also have predictions. Compare both of them. Compare both of them. You'll get the accuracy. Akil, how is accuracy calculated? Simple. See, your actual values. Assume these are your actual values and these are your prediction values. Actual values as per the first record says 0. Prediction also says 0. Actual value in the second row says 1. Prediction also says 1. 0, 1, 1, 1, 0, 1, 1, 1, 0, 0. So in this way, you will have the actual values and predicted values. Actually, why we did not write to friend? Focus. How can we have any other number? How many different labels we have in the Y column? Only two, 0 and 1. 0 is representing customer rejected the personal loan. 1 representing customer accepted the personal loan. Right? So you can have only zeros and 1. Apart from zeros and 1, you cannot expect any other number. Impossible. Right? Now these are your actuals and these are your predictions. So when you try to calculate accuracy, you know, compare both of them. Accuracy is defined by the formula is true positives plus true negatives by true positives plus true negatives plus false positives plus false negatives. What is this true positive, true negative? What is this, Akhil? Are you confusing us? No, friend. These are the important metrics of classification algorithm. You know, the important metrics of classification algorithm. We are talking about accuracy, right? But you know, in the backend, accuracy uses this particular formula. Only then it gives you the result. Okay. Can you please tell me what is this true positive, false positive? Right. So, you know, every problem that you take, a classification problem, you'll have a positive class, negative class. Am I right? Yes. What is the positive class that we have here? Customer accepting the loan. If the customer accepts the loan, we'll get profits. That is the positive class. What is the negative class? Customer rejecting, 0. Okay. So true positive means customer is, the positive class identified as is. So one identified, the model is also predicting 1. Okay, then true negative, the negative class predicting as is. False positive, What is a positive? Positive is nothing but 1. 1 identified as 0. So is there anything like that? No? Okay, let me keep it over here. And false negative, 0 identified as 1. 0 identified as 1. Right? So, how many true values detected? Yes, that's what. So true values identified as the true cases. In the backend, accuracy uses this particular format to calculate, the accuracy. In the same way, yeah, if you remember, accuracy plus error is equal to 100. We have understood this, particular relationship between accuracy and error. So if accuracy is using this formula, you know, error uses 100 minus accuracy. So obviously percentage, right? So it will be 1 minus accuracy. So, the false cases comes into the numerator by total. So this particular metrics are available in confusion matrix, the next topic. Okay, so we'll understand the confusion matrix so that it will be very clear. The name itself is identified as confusion matrix. When you try to understand it, you'll get a bit confused, but it's not that confusing. Still, if you pay attention, you can grab it easily, friends. In order to get the confusion matrix, again pass both actual and predictions. So I'll get the confusion matrix. Let me print the confusion matrix. So I see confusion matrix for test data. This is for test data. I'm not doing for train. Okay. So tell me, so people who have knowledge on confusion matrix. So here we have in total 4 values, right? Okay. So tell me what is the value for TP, TN, then FN, FP. Come on, friends. What are the values for these 4 metrics with respect to the confusion matrix? TP is 1259. Not exactly, not exactly. No. Hmm. Sure. Are you guys sure? Hmm. Okay. One simple logic. What is the positive class we have here with respect to just answering the questions? Okay, if you are that much confident, even confidence matters, friends. What is a positive class that we have, friend, in the data? With respect to y column, we have zeros and ones, right? What is a positive class, negative class? Okay, okay. Just answer the question. This question. One is positive or negative? One is positive or negative? Zero is negative. One is positive. Right. Wonderful. Now let us map. I see majority of you, not majority, I see all of you. Zero is negative. Yeah, this is perfect. If a customer accepts it, it is a positive class. That means we are going to get some profits. And if they reject, we'll get kind of we don't get lost, but still it's waste of running the campaign and all, right? So our ultimate objective is to gain profits. When do we get profits? When the customer accepts. So the positive class is nothing but customer accepting the loan, personal loan. So one is the positive class and zero is negative class. This is clear. Now let me keep it over here. 1259 97 28 116. So when I asked you to give the values for these metrics, majority of you told me TP is nothing but 1259. Do we have 1259 customers accepting loan in the data set? Within the data set, do we have 1259 customers accepting the loan, the personal loan, or are they rejecting? What is the majority class? Yesterday we performed value underscore counts. This is where the actual concept comes from. When you start thinking, you'll correlate with your answers. By default, I tell you friends, all of us, will take this as true positives. Am I right? This is nothing but TN. This is nothing but TN. And this will be TP. Why? Only 116 customers. Okay. So they are actually accepting. Even the model is also predicting that these 116 customers will, you know, excuse me. These 116 customers will also, accept the loan. Then what is this particular 28? This is FN, false negative, very danger. 97 represents FP, false positives. They are ready to accept, but our model says they don't accept. Right? So this is very dangerous case, friends. Not with respect to each and every domain, but especially with domains like life sciences, healthcare. Okay, anything related to life. Okay, so this particular number has to be brought down. It should be very less, probably 1, 2, or 0. The reason is false negatives will impact the results more. It shows a lot of effect. Okay, so don't assume this the first value is true positives. It is true negatives. The diagonal will be true cases, friends. True negatives, true positives, false positives, false negatives. These are danger. These mean that the patient has cancer, but our model says the patient does not have cancer. So, when our model says this person has no cancer, but still if he or she have cancer, what they do? Will they go under any medication? No. If they don't go under any medication, they'll die. This is accepted, even though the person does not have cancer. My model says, this person have cancer, so they'll undergo some kind of medication. They'll later come to know that they don't have cancer or any other disease. So this is accepted. But this case is very dangerous. Right? So false negatives should be brought down, friends. It's not we compromise or we get adjusted to the accuracy. Not every time we focus on accuracy. No. By looking at accuracy, what are the metrics? We'll also focus on these things. Right? So a clear understanding of confusion metrics. Then I'm also getting the report, classification report on the same test data. Okay, so where I see, let me print it. So this is the classification report for the test data, the precision. Okay, so precision, recall, F1 score. For time being, F1 score is nothing but the harmonic mean of precision and recall. Okay, so if you want to decide whether a model is performing good or not, we generally consider F1 score, friends. Okay, F1 score, if it is close to 1, the range of F1 score will lie between 0 and 1, right? So if it is close to 1, we say obviously the model is performing well, and you know those models can be used for further development. So this is the classification report of test data, and I'll do the same thing. I'll do the same process on train data as well. Okay, I'll bring my model and I'll get the predictions on train data. Then I'll get the accuracy on test train data set. The train data set says 97% accuracy, 92% on test, 97% on train. Accuracy is more. No, with respect to accuracy, they are performing good. But we should not compromise on the other metrics also. When you actually finalize a model, all these parameters have to be considered with respect to the domain. That is the reason I am telling you, domain plays a crucial role. If I get the same results with respect to a life sciences domain, obviously I'll reject this model. The reason is, who is going to take 30 or 35 people live, right? So it's not possible. It is not accepted. I'll get the confusion metrics on test data, on train data as well. See, FN says 58. False negatives, we have our 58. So something that we have to look in, not accepted. And also get the classification report on train data. This is the classification. What is the F1 score? It's good, 0.97. Okay, so just we have built a vanilla model, but let us do one thing. Why are we sticking to 5 nearest neighbors? Let us experiment with multiple values of k. For that, I'm coming up with a range of values, okay, from 3 till 51 with step size 2. So that means I'll get 3, 5, 7, 9, so on till 49, right? So all these values are captured in k values. Then I'm defining an empty list to capture my train accuracies, an empty list for capturing my test accuracies, and an empty list for capturing my accuracy differences. In order to get the difference between train and test, okay, those differences also I'm recording. Right. Now I'm running a loop. I'm defining a loop. Okay, so what does the loop says is the same code for k in k values, starting with k is equal to 3. The same process, friends. N neighbors take 3, so 3 nearest neighbors will be considered. Then build the model, get the predictions on train data set, then accuracy score of train accuracy will get, again this train accuracy append to train accuracy list. In the same way, get the predictions on test data set, get the test accuracy, append the test accuracy to test accuracies empty list. Okay, and finally calculate the difference between train accuracy and test accuracy for that particular k, and append the difference to accuracy underscore differences list. So when I run all this loop for all the values of k, it performs the same operation, okay, and it in a fraction of seconds in the back end it completes the iterations. See, it runs for all the different values of k friends, 3, 5, 7, 9, so on till 49. Done. Okay, so for better understanding, I'm converting the output to a data frame as a table. The first column contains k values, the second column contains train accuracy, third column contains test accuracy, and the fourth column contains difference. Where am I storing? Results df is the data frame. Results df. See, 3, 5, 7, so on till 49. For 3, what is the train accuracy, test accuracy? The difference. 5. So if you take different values of k, probably you'll get different values of accuracies. The difference, yes. And from here, can we get the best k value with respect to the accuracy? Yes. But instead of comparing the values in a table, it's better if we go and plot them. It's easy for us to take the best k value. For that reason, I'm plotting all these values as a line chart. Excuse me. As a line chart. The blue line it is representing train accuracy and the orange one is representing test accuracy. So starting with 3, then 5, then 7, then 9, so on till 49. So on x-axis we have k values, on y-axis I have used accuracies. So tell me which k value should I consider? By visualizing this plot, tell me the best k value that can be considered. What do you see? If you closely observe, for k is equal to 3, the train accuracy is 98%, and test accuracy is 93. Yes, so these two are very high, and they also hold that 5% standard with respect to real time. So obviously, I see the majority, no, the high accuracies we are observing with respect to k is equal to 3. If I take 5, there is a drop with respect to the accuracy. It is becoming 0.97, 97% on train, and less than 92 for test. So obviously it is 3 compared to the rest of the k values. All of them are very less. So I can say that k is equal to 3 is giving me the best accuracies. But still, let us try to improvise this accuracy, the output, by doing hyperparameter tuning. Hyperparameter. The parameters that we have, we are actually tuning the model by passing different hyperparameters. Okay, so for that, I'm taking different values of k, n neighbors, and weights. Weights is a parameter that we have in KNN friends, K neighbors classifier function. So uniform means all the neighbors will be treated as same, and if you keep it as distance, depending on the distance between the neighbor and the new data point, you know the preference will be changed. So lesser the distance, more weight will be assigned. More the distance, less weight will be assigned. The same concept. If it is with distance, what metric has to be used? Euclidean, Manhattan, Minkowski. Okay, so I'm using all of these and I'm storing in a dictionary. What did we do? I'll tell you. Now comes grid search CV. What is this grid search CV? Hyperparameters should be tuned manually by the user. Yes, because we are the one who have to define these, right? So we'll talk what is this grid search CV and how this is going to work. So we got good results, friends. To be frank, we got 98, 93. This is enough, but still, in real time we don't compromise on the output, right? So we'll also perform something called as tuning by taking the hyperparameters. What we do is, you know we'll come up with the different techniques. One of the widely used technique is grid search CV, grid search cross validation, and there is one more technique called randomized search CV. Randomized search CV, randomized search cross validation. So what are these two? These are two hyperparameter tuning techniques. Okay, so what does grid search CV do? What does randomized search CV do? Let us understand. Grid search CV, it takes, inside grid search CV, you are coming up with multiple parameters, the function, param grid, the scoring part, CV is equals to 5, verbose, and jobs is equal to -1. So you are actually coming up with the different parameters. So grid search performs each and every combination. It takes each and every combination and it tries, it builds the model and it gives the output. Okay, whereas randomized search, it does not go for all the combinations, only it performs random combinations, it gives the output. Out of the random combinations that were being performed, the best result will be given as the output. That makes the difference between grid search CV and randomized search CV. Then, when grid search CV has to be applied and when randomized search CV has to be applied. If the data set is small, and if you are computationally, if your system is not that much supporting, you know um, if you're in that case, you better go with grid search CV. If you have less number of hyperparameters, if the data set is small, okay, then go for grid search CV. If the data set is large and if the hyperparameters are also more, then go for randomized search CV. The reason is grid search CV takes all the combination, three uniform Euclidean, three uniform Manhattan, three uniform Minkowski. So this is three different combinations. Then comes five uniform Euclidean, so on. In this way, we have combinations formula, right? So these many combinations we get, right? So since our data set is small, I'm just exploring with grid search CV. But if you are working on a big data set, or say if your hyperparameters are more, KNN has very less hyperparameters. But if you go for decision tree, algorithm like decision tree, you know, this entire sheet gets filled for the hyperparameters. Those many hyperparameters we'll observe with respect to decision tree, my friends. There are a lot of hyperparameters for decision tree kind of algorithms. Ensemble techniques, random forest, bagging, boosting, ADA boost, XZ boost. So they all have n number of hyperparameters. So in general, we don't go and use these many grid search CV for decision tree, or even still, even if the hyperparameters are more, the data set is small. Again, we can go with grid search CV. But if you feel that data set is big, don't go with grid search CV. The reason is your system may crash. Crash in the sense it takes, it gets hung. If not, go and use Google Colab. Go and use Google Colab IDE for executing the code. The reason is in Google Colab, it allows to change the runtime. We generally use CPUs, am I right? Central processing units. How many of you have GPUs, graphical processing units, systems which support GPU? Anyone is using GPU here? No? GPUs are capable of extending themselves with respect to computation funds. In Google Colab, you have a specific option to change the runtime from CPU to GPU. If not, you can also change it to TPU, tensor processing units. Okay, so this particular feature is available in only Google Colab IDE. Don't try to do such kind of things in Spider or Jupyter. The reason is your system may harm. If you are having the access, yes, you can proceed. But for the friends in general, no one purchases GPU or TPU. Majority of us will go with CPU only. Okay, I know why. The reason is GPUs are expensive. The main reason is GPUs are expensive. Compared to GPUs, TPUs are more expensive. But you get this runtime option, changing the runtime option in Google Colab. So the best option is in Google Colab. Anyways, let us go back. You get it? Right. I hope grid search CV is clear. So what I'm doing is I'm initializing the grid search CV where I want to get the scoring part will be F1, optimizing the F1 score. Okay, and the param grid takes from this particular dictionary, friends. This particular dictionary will be considered for the param grid. And CV cross validation. I'm going with five-fold cross validation. Five-fold cross validation is nothing but your data will be partitioned into five parts. Uh, say yeah, so this is our data, right, that we are going to use for the training purpose. So this particular data will be partitioned into five different parts. Assume this data set has 1,000 rows, so five parts will be 200 rows for each and every part. So in each and every part you have 200 rows. So what is CV is equals to 5 is it breaks or it partitions the data into five parts. Then in each and every iteration, in each and every combination, four parts will be used for testing and one part will be used for training. So this process happens by keeping all the parts once as training data. Okay, that is nothing but CV is equals to 5. So that means every record will be part of test data set at least once. Okay, so I am going to initialize grid search. Done. Then I am fitting this grid search on the train data. Okay. Once after fitting the train data, if you observe, see, it is started fitting five folds on for each 30 candidates. So 5 into 30, you get 150 fits. It is taking time. Done. It's done. Can I get the best parameters out of all the grid? Yes, it is stored in best params and best estimator. in best KNN. So I'm storing these, excuse me, in the best KNN variable object. So I'm printing the best parameters to the console. So these are the best parameters where I see the best results. Best parameters are metric being Manhattan, number of neighbors 5, weights as distance. So if you keep weights as distance, metric as Manhattan, and number of neighbors as 5, I'm going to get the best output. Okay, so now I'm using the best model, okay, where I have stored in the best KNN. I'm using the best model to predict on the test data set. I'll get the predictions. Once after getting the prediction, I also have the actual. I'll get the accuracy. Let me get the accuracy. It is 0.2892, 92% test accuracy. Let me also get the confusion metrics. These are not required, but still, see, it got reduced a bit. Compared to the previous vanilla model, I see a difference with respect to the false negatives. Right. Then I'll also get the classification report on test. So this is my classification report. It is 0.96. The F1 score 0.93. Yes. So assuming that we are going to deploy this model, I am finalizing this model. Okay. So I am saving it. What am I doing? I am saving it. So if you want to save the model, you are supposed to use joblib or pickle libraries. So in joblib or pickle, there is a function called dump. Okay, so this dump function will save the model. What is the where is the model? Model is nothing but best KNN. So I'm saving the model with the name best underscore KNN underscore model dot pkl. PKL represents it's a pickle file. Okay, I'm saving it. It's done. Where it got saved? It saves in my local machine, friends. In the local machine. Then I'm also printing that a message model save as with this file name. Akhil, can you show us this model where it got saved? Yeah, sure. Yesterday, what did we discuss? By default, when you are trying to save anything with respect to the code, all the files get saved in the current working directory. Okay, in the current working directory, your model gets saved. So let me open the current working directory. Did it execute? 1 minute. Yep. So if you see, this is my model which got saved at 8.3. It's 8.3 now. Right? Now I'll use this model and I'll go and I'll predict the new data. Is it possible? Yes, that's called as deployment. For deployment, I'm going to use a basic framework of Python that is called as Flask. I don't know if you guys are aware of Flask or not, but Flask is a lightweight framework of Python which is used to build, web applications, friends. A basic application can be built using Flask. Right. I'll quickly explain what I'm doing over here because it's a one-time code that we have to execute. I'm importing Flask and request. So Flask for creating the website, web application, and request to handling the request that server gets. The HTTP, request that we generally get to the server. So the request will be taken care of them. And joblib is used to load that data, the pickle file that we have saved. So in order to load the pickle file, the model again we are using joblib and pandas for data manipulation, standard scalar for standardizing the data. So initially I'll load the pickle file back. Okay, here I have saved and this is loading, dumping, loading. Once after loading the model gets loaded into the model and I am actually initializing the web application using Flask, right? Then I'll start with a custom defined function by keeping the HTML code. So this particular HTML code is for the front end of the web application, friends. The basic front end. I want to keep KNN prediction the title. Okay, so under the KNN prediction, I also want some options like upload a CSV or Excel file, right? So HTML language contains tags, right? So it contains head, body, then tail, all the parts, right? So this is not a cup of tea. Let us not go into this HTML code for time being because it takes a lot of time to explain all these things. This is just to I tell you what exactly is this. I tell you. Then one more method, one more function for predicting the output, where if you provide a data set, okay, so if you don't provide any file, you'll get a message like no file provided. What if you provide a file? This file, if it ends with CSV, pd.read CSV file will be executed. If you are providing an Excel file, read underscore Excel file will be executed. If not, if you suppose if you provide any other file with any other format, it will throw us an error, unsupported file format. Just we have kept the code for only two file formats, CSV and Excel, and for other file formats you get an kind of warning message, so stating that please upload a CSV or Excel file. And then the same code, friends, whatever the code that we have used in the previous model building part, I have kept the same code. Initially on the new data also, it checks whether these columns are available or not. If the columns are missing, again a warning message will be sent. Missing columns, required columns in the file. Once, if you don't get this message, it starts undergoing line by line. CCAVG gets converted into 12. Then uh, only the required columns will be extracted. Then standard scalar will be applied. Okay, it gets initialized and it gets applied on the data to get the transformer results. Then the model that was loaded initially in the using joblib, okay, the model will predict the results on the scale data. Okay, results will be added to the data with a name personal loan. To the data, in a new column under personal loan, the predictions will be there. And I want these predictions in a table format. Okay, again you have a HTML file for showing this table, HTML code. If you find if it gets any kind of exceptions, it returns a string E. Right, then it is also running the application in the debug mode for easy debugging. So that is the reason now we can easily debug the code. Right, so let us execute at a single go. See friends, I'm executing. The moment I executed, see it is still under execution. It throws us some kind of URL. Okay, so if you click on control or copy this particular link URL and open any of browser, any one of the browser, paste it and click on enter. In the back end, it gets executed. The HTML code gets executed, and you see the first part will be. Now I can able to explain. What should be the title? KNN prediction. KNN prediction should be the title. Okay, what is the style? I have kept the style over here. Then what are the options should I have? Upload a CSV or Excel file. Upload a CSV or Excel file. Then I should also keep some kind of buttons. Yes, to upload the file. Then, and once after the uploading the file, you should also, the end user should click on submit button so that the predictions get, the model gets the predictions, and these predictions get added to the table. So we are supposed to upload a file, CSV or Excel file. For that purpose, I have a test data set. Let me show you the test data set first, because I should, show it to you, right? See, this is my test data in which I have all the columns. Okay, but do you find any Y column here? Is there any personal loan? No. Rest of the 11 columns, 11, no 11, it's 13, because in total 14, right? 14 including output. So 13 are inputs. So it drops off ID and zip code, and rest of the 11 will be used for the prediction. Let's see how it is going to, you know, do the predictions. Done, uploaded. So I'm clicking on upload and predict. That's it. That's it, friends. If you see in the last column, we can say that, person one, our customer ID with ID one, he or she will not go for personal loan. But person customer four, yes. So we'll target this person, right? So if you have the customer details, so we can get their prediction done. In this way, we can deploy any of the model, and not only for KNN, we do it for n number of algorithms. Whichever algorithm gives you the best results, depending on the domain you are, uh, promising results for the client, that particular algorithm, the model will be deployed, and depending on the contract that we take with the client for X number of years, we are going to maintain this model. We'll continuously monitor the results and maintain the model. We'll do monitoring and maintenance also. This is how CRISP MLQ works, the end-to-end project management methodology. Okay, so it's not possible to teach monitoring and maintenance, but in future we will also go and come up with some kind of tools how monitoring and maintenance is done on any model in real time. So we'll understand all these things in the coming program, friends. So that's all with respect to this session, and it's time for our you know technical questions. Thank you so much for your valuable feedback. If you guys are supporting us in this way, we'll plan n number of programs in the coming days as well. But one thing that we request, or we are expecting from you guys is, if you are joining the sessions, on daily basis, and if you are encouraging us, we are ready to provide n number of programs to you at free of cost, friends. The reason is we had lot of experience in real world, and we want to share all these experience with you guys. Might be majority of you are students, right? So these sessions will help you a lot. Neural networks we are going to cover in the next program, so we'll be informing you, my friend. Okay, you know so no no worries about that particular thing. Everything will be covered, no issues. Yep, any technical questions? Thank you so much. Right, so the next program Okay, on this occasion, I would like to take up a moment to explain about the next program. So, friends, the next program will be on Power BI, and how many of you are aware of Power BI? I'm not sure, but in real time, if a person is aware of Power BI, if you have Power BI as a skill, you are being paid lakhs. To be honest, lakhs, right? So, what is Power BI? Power BI is nothing but it's a business intelligence tool where we can visualize the data, right? So the next program is on Power BI. So we are going to plan this Power BI program post the Pongal vacation. When we are going to start, what is the starting date? Everything will be communicated in the WhatsApp communities. So be active in the community. The only mode of communication between you and us will be like WhatsApp friends, WhatsApp and Telegram. That's it, right? So that's okay. Even this program may end, but the bond between you and our organization is no more going to end. That's okay. But friends, one sincere advice from my side: do hands-on. If you don't, take any use case, and if you don't perform hands-on, you will not get anything, right? So focus on hands-on parallelly, right? So Python, not only Python, you take any programming language, people coming from different domains, and if they are able to, learn programming languages, the success mantra is practice. That's it. Apart from practice, nothing else. So just focus on hands-on, right? It's not a movie. I tell you all the time. Okay, so we are supposed to focus on hands-on as well. So any other questions? Thank you. And I request everyone to join the upcoming programs as well. Yep. If no questions, thank you so much, friends. You are really amazing for joining the session on time, and you're making the session very interactive. So that is the reason I am also being involved a lot, and I'm completely looking out to share my entire experience, whatever I have in the real time. So once again, a great thanks to everyone. So thank you so much. I want every one of you to join the next Power BI sessions as well. So with respect to the certificates and all, friends, it will be communicated in the WhatsApp group. So be active. If there are false positives in high, see, false positives, even if they are high, that's okay. But false negatives, no, not accepted. The reason is that's what a person having disease, and my model says no disease. This is false negative. But a person does not have disease, but my model says, I mean, a person having disease. I'm just looking at the messages and I'm getting confused. That's okay. False negative is nothing but a person having disease and model saying that, model predicting as no disease. Okay, whereas false positive is person is not having disease and model predicting as yes, the person having disease. So that is not danger. Okay, so in false negative case, it is danger, friends. So obviously we have to retrain the model. Tuning has to be done. Sure. All the details will be posted in the group. Okay, so I want everyone to just go through the details. I wish everyone a happy Pongal. Okay, celebrate the festival well, and post the festival, join our sessions. Right. Once again, thank you very much for joining the sessions and making them extraordinary. Right. So until the next session, right. So until the next session, keep doing practice the code time again, acquire good amount of knowledge. Okay. So we'll again connect in Power BI session. Take care, friends. See you signing off.